See now? So what should be your program structure? See, this is how you can derive. This is the way you should have done in 118 to write the code. Okay? So you should get the logic first. So basically you start with what? I equals 0 to n minus 2. I basically pick one element, I equals 0, first element, and, well, let me write the code, write a summation. So the pseudo code should be, for I equals 0 to n minus 2, I pick some temporary variable, or you can just say a of I, but you can say temp is a of I, and then what? Go over from the subsequent elements. So your j should be from I plus 1 to what? The rest of the array. So if I start from this, I should start from comparing from the next element, I plus 1. So whatever is the index I, start your comparison from the subsequent element, I plus 1. Okay? This is your starting from I, so you should start comparing from I plus 1, which is this index. Right? Up to n minus 1. And all you are doing is, if a of I, if you don't have a temp here, I can just say, don't need to have a temp. Why you are wasting another memory location? Just say a of j. Right? Return false. So if you are equal, return false. So you are basically terminating the whole process. If they are not equal, keep checking it. Right? So this is your inner for loop, this is your outer for loop. So if you are able to run both this for loop and get the outer for loop up to n minus 2 and come out without returning false, what does it mean really? If you are running this every time and then even this every time, the array has unique elements. Right? Is that clear? You are going through for given I the inner loop, and the inner loop runs from index I plus 1 to n minus 1, because you are picking an I and you are comparing from there. Because you don't need to go back and compare, you already compared, right? That's what I mean. So just picking up an I and going from there, I plus 1 actually. And you need to go with the I, how long? The last but one element, n minus 2. Because index runs from 0 to n minus 1, right? So you go up to n minus 2. That's your last value of I. When you pick up that, you're comparing that with I plus 1, which is what? n minus 1 element is the last element. Okay? So how many comparisons you are doing? It depends now. Why? Or it does not depend. You have a worst best average case here. What's the best case scenario? Before that, we have to know what's the basic operation, right? So what's the basic operation? Comparison. You're comparing a of I with a of k. So comparing two integers or elements is a basic operation. So you have to know how many times you do the basic operation. So is there a minimum number of times you will do a basic operation? One. One time you can do, right? So when that can happen? The first two numbers are the same. So if I have a 10 and 10 here, I pick up this 10, compare with my I plus 1 index, they are matching, so I can say return false. So the best case is one comparison. And when that can happen, if the first two elements are the same. When the worst case will happen?
Yeah, probably the two.
Huh? When the last two elements are the same or none of them are same, which means the array is unique. Right? So there can be two scenarios where we have worst case, which means you have to go all the way to the end, right? So that's what we have to find. Best case is 1. There's nothing to do any math on it. But the worst case, you have to do the math and find out what's the worst case. So what will be the math expression for the worst case? You have to do your I, the outer loop, go from I equals 0 to n minus 2, and the inner loop goes from j equals I plus 1 to n minus 1. You are doing this comparison all the time, right? So for all values of those index, well, variables. How many comparisons you are doing for each inner iteration? Each time, like you're running this J loop, how many comparisons you are doing?
7.
One comparison, right? For a given I and J, how many comparisons you are doing? You're picking up an A of I, going through the J loop, J equals I plus 1 to n minus 1. You're doing one comparison for each iteration of the inner loop, right? So for each iteration of the inner J loop, you're doing one comparison. So, 1. Okay? So now you have to simplify this. Okay, so this is the worst case. Worst case what? Number of comparisons. So how do you simplify this? Start with inner one, inner summation. So inner summation is J equals I plus 1 to n minus 1 and 1. So it should be simplified as, the inner one has what here? 1. So what formula should apply? The upper limit, lower limit. So tell me what's the answers. I am writing outer summation. What's the inner one? Someone from center, middle? What's the formula? Look at your notes. We have the limit, upper limit, lower limit, 1. What should be the answer formula?
It's going to be a minus 1 plus a minus 2.
I plus 1. Isn't it? Upper limit minus the lower limit plus 1. That's why I keep repeating it like that, upper limit, lower limit. So whatever it could be, you have to apply that limit. We have 1 here. Okay? So now apply the, simplify it and tell me what should be the answer. So you have sigma I equals 0 to n minus 2, n minus I minus 1. So I'm just rewriting the I in 1. So. Okay? And this is where you can make it complicated if you want to, but I can tell you the easy way to simplify this further. You can apply the formula if you want by breaking it into two terms, n minus 1 and the I term, and take the summation inside and split it into two summations and so on. You don't need to do all those things. What you can do is just apply the I limit. I equals 0 to n minus 2, right? Isn't it? So let's keep it the same way. 1 minus I doesn't matter, right? So let's do it the same. N minus 1 minus I, right? That's what it is here. Okay? So what was that I said? You can do it two ways. If you wanted to do it complicated, I'll give you the starting. You can go ahead and do it as a homework. Split it up and take a summation side and try to simplify that. Don't want to do that. What you need to do is just substitute I values. So I can say this is what? N minus 1, right? Minus I. So when I is 0, it is what? N minus 1 minus 0, right? When I is 0, substitute I here, it is n minus 1 minus 0. Then n minus 1 minus I is 1. What is that? Minus 1. Similarly, n minus 1 minus 2. So on, up to what? N minus 1 up to n minus 2. I is up to n minus 2. So now you simplify this. This is quite easy now. Why? N minus 1 minus 0 is what?
Minus 1.
1 is n minus 1 minus 1. What about next? What about the last one? You have n minus 1 minus n minus 2. So So n minus 1 minus n plus 2. Right? So this is the whole thing is what? 1. Right? So this is nothing but n minus 1 minus n plus n minus 2 plus n minus 3 plus so on up to 1. This is a very familiar form. Can you simplify, can you write your final answer based on this? N minus 1 plus n minus 2 plus 1 up to 1. Slightly in a reverse order, but you should be able to find out what formula to apply for this. This is in what form? Just reverse the order it is. It is 1 plus 2 plus up to n minus 3, n minus 2, n minus 1. So this is of the form what? 1 plus 2 up to n. Instead of n you have up to n minus 1. Right? If you have up to n, the formula would have been what? 1 plus 2 plus up to n is what? N times n plus 1 over 2. So instead of n you have n minus 1. That's the only thing, right? So this should be equal to, original thing should be equal to what? Somebody can substitute for n what? You have 1 plus 2 up to n, the original formula, but in this current scenario you have 1 plus 2 up to n minus 1. Right. Can anyone get it? Instead of n you have here what? N minus 1. So instead of n substitute n minus 1. So I'm going to have for n minus 1. So this n is n minus 1. So this should be then what? N minus 1 times n minus 1 plus 1 over 2. Right? So this should be n minus 1 times n minus 1 plus 1. This is n minus 1 plus 1. What's that? N. So that is theta of what? Okay, so you understood how I got it? Instead of n, you have n minus 1. So the formula is n times n plus 1 over 2. So instead of n, put n minus 1. So n minus 1 times n minus 1 plus 1. And n minus 1 plus 1 is just n. And you have n minus 1. So this is theta of n squared. Okay? So the worst case is what? Theta of n squared. Best case is just 1. Worst case is n squared. Okay? The worst case you have to do theta of n squared comparisons. Clear?
If that's the worst case, wouldn't it be theta of n squared?
No. We are just now presenting everything using theta. Worst case. Okay? So now, what should be the average case? Is it easy to find out just using some math analytical step like this? Average, you don't know, right? How many comparisons you have to exactly make on average. It depends on the array. Yes?
And you say stop you at the end, so you can talk about something like the quiz or something?
You do it all the time?
It's 12:46.
What did I say? I talked about the quiz. Yeah. So whatever I cover up to this one. Okay? Alright, let's complete it. So, the average case, so this is like the project. So the average case depends really on the array. Right? So it depends on how many, the given array, and when can you find two different elements to be, two integers to be the same thing, right? Yeah? On average case, comparisons. But if it happens out to be something like these two are same, when will you catch these two 7s? You have to take this 4, go over the entire array, then take up the 5, go over the entire array, and then take up the 3, go over the entire, and so on. Then only you can catch after a while the 7s are same. Right? So on average, you cannot really say what is the exact number of comparisons on average. Right? It depends on the array very much. Not only that, remember you want to find whether the array has unique elements or not. Right? So the average number of comparisons will also depend on the range of the integers you want to fill up with the array. So let's say I have an array of size 100 elements. So I have array of size 100 means 0 to 100 different elements. Right? The array size is 100. Let's say again the array size is 100. If I want to populate that array with integers in the range from say 1 to 10, right? Do you think can you fill a 100 element array with unique integers whose values can be only from 1 to 10? No way, right? The 11th integer you fill up there should be definitely one of them that is repeated again, right? So what I am trying to say, on the other hand, let's say same 100 element array, the range of the integers can be say from 1 to 1 million, right? So the 100 integers that you fill up in the array could be more likely to be different, right? Because if you fill up them with random integers, you have a random number generator, and you fill up each element in the array with whatever number generated by the random number generator, and your range is so huge, it's more likely that you fill up each index in that array with different elements, right? You see what I mean? So the average number of comparisons not only depends on the array size, it also depends on the range of the values of your elements in the array. Right? So I assign another variable in your project, if you will read it, called the variable m. M is the maximum value of any element in the array. That defines the range. So you're going to work with the positive integers. You can start from 0 or 1, so whatever it is, your range can be up to only a maximum value. So we're going to generate random numbers and fill up the array of a given size. And the size of the array will vary from what? I'll give you for each of you a max value. I won't even give you the array size directly. For each of you, I will assign 2 max values. You have to work independently on them. Let's say you have a max value of 100. What does it mean? The value of any integer in your array can be up to 100. And the array size is a variable. You will start with a particular value of n, which is 0.1 n, which means your array will have 10 elements. You have to fill up an array of 10 elements with values ranging from 1 to 100 randomly. Okay? Run your program, implement this program, collect what? Number of comparisons. Count the number of comparisons you will be doing. Okay? And then, when you define how you count the number of comparisons, whenever you do a comparison, have a variable that keeps incrementing whenever you do a comparison. Right? That should be your logic. And then, that's one complete run of your program. So, record the number of comparisons. And then do it for 0.2m and so on. Before that, before doing this, repeat this say 100 times or 1000 times, how many times you want, as much as you want, because you want some statistically correct results. Because this is one run of your algorithm, right? You will get some number of comparisons. Repeat this program, fill up your array with some random numbers, again do this thing, count the number of comparisons. Add up all the things and take the average. Right? Then similarly for n equals 0.2m, do the same thing. Now your array has 20 elements. Right? And then n equals 0.3m and so on. Up to n equals m and then 2m. So it's 100 elements and then 200 elements. So for each of them, so we'll just stop in a minute. For each of them you will count the number of comparisons and plot what n versus the average number of comparisons. The size of the array is the average number of comparisons. Okay? So go over the project. I'll try to record like what I explained to you briefly about the project and